Okay, now I'm gonna have a go at question number 19. Can you please explain the calculation process of pairs trading? Wow, it's very hard. A question like that can, be answered. I can talk for 3 hours on this, but I think if you, it helps me a bit if you are more specific. But if you go to have a look at my answer for question 13 on page 13 and 14, I think that should give you some clue. So 13 was about how to arbitrage by dual listing. This was using the example of what was it? I think the Eurex versus Singapore Exchange. After this, trading the divergence, convergence of two correlated instruments. So this is about 10-20 pages after that. It's a little bit different. This is trading two things that are actually different but very similar, namely the DAX versus the Euro Stoxx 50 futures contract. So I already spent quite some time talking about that, but I could just maybe add an overview here by going to let's say lecture 1, and I think you are talking approximately around page 90, somewhere around there. Now the thing about changing pairs trading is that, okay, what is the theory? What is the assumption behind? The assumption behind is when you are trading the DAX versus the Euro Stoxx, the actual market levels of these should be overall be connected by a certain ratio, in this case the ratio is 0.34. Okay, now let's just say that is true. Okay, so therefore every time, what you're saying is that every time the DAX is moving, then if you multiply the DAX value by 0.34, you should get the value for the Euro Stoxx. Now that's the theory. Okay, whether you agree with it or not, that's a different matter. But let's just say it is true. Okay. Now we saw earlier that the DAX was trading at a value of 6,800, and then the Euro Stoxx 50 stocks. These people can't even spell stocks. STOXX is trading at 2011. Okay, now let's say my theory is that when the DAX is trading like this, the Euro Stoxx should be just trading at whatever the DAX number is multiplied by 0.34. So the moment they deviate from each other, okay, I think there is an opportunity for me to trade. So let's say for some reason the DAX is trading where it is. What happened? The DAX is trading where it is, but the Euro Stoxx are trading at 2,305 and 6. Let's just say that was the case. Okay. Then the question is, how can you take advantage of that? That's the discussion we're having here. Now, first of all, which market is more liquid? Well, here the bid offer is half a point between 6,800 and 6,850. Here the bid offer is 1 point. Not only that, this is half a point divided by 6,800. So in percentage terms, it's even smaller. Okay, so the DAX market is relatively the more liquid of the two. So like I said, the less liquid market is the one where you should be a price maker. So you make wide prices and you hope that somebody will come and either hit your bid or lift your offer. The more liquid market is the one for you to do your fast hedging, and you can trade in and out of it, a lot easier. And if you need to unwind your positions, okay, the liquid market also is a lot easier to do so. Now, there is another thing. Well, we just said that the DAX should be connected to the Euro Stoxx 50 by a ratio of 3.4. Well, now it doesn't actually say anything about the value of these contracts. So for the DAX, it's actually 25 points per contract, whereas for the Euro Stoxx, it's 10 points. So if you do a rough calculation, you can see that 6,800 times 25 is equal to 170,000. Okay, whereas the Euro Stoxx, it's going to be 23,110. So that is why for every one contract you trade here, you need to trade 7 contracts. So maybe you long one and then you short 7 here. Okay, now how many contracts you trade depends on the individual, the contract value of one contract, and how many contracts you trade are a separate discussion to whether these actual market levels, these numbers themselves, are starting to have a divergence or whatever. That's a different discussion completely. Okay, so you can if you look at this example here, so now we established 2 things. The first one is we think the Euro Stoxx, the number, okay, should always be the DAX level multiplied by 0.34. Now, if you're going to go long one and short the other, the question is, okay, now if I see a divergence, how can I make money from that? If they're going like this, and I think that they sooner or later need to come back, how can I make money? Well, the first thing is you have to trade with roughly same contract value to minimize your risk. Oops. Hold on a second. You need to trade 7 times of the Euro Stoxx 50 versus one time of the DAX, and when you look at the market where you are going to put out your own prices as a price maker, so first of all you watch where the market is, okay, and this is the actual, okay, and you calculate what you think should be the theoretical, where you think it should be, and you think it should be here and here. Okay, so it appears that on the bid side, okay, if you really were able to buy at 2,311, okay, it is cheaper than what you think the value should be in theory. Okay, now the thing is, you wouldn't trade like this because you want to have some kind of protection when you put on a trade. So when you buy, you will probably buy at a lower price, or when you sell, you want to sell at a higher price, in order to leave yourself some protection buffer. Okay, that is why we have this formula here. They said you take a credit. This is not credit in a fixed income sense. It's credit as an additional pricing gap to protect you. So even though you feel that in theory this is where the price should be, you are not going to buy at 2,312. You're going to buy at 2,310. and you're not going to sell at this level here. You're going to add 2 to it, so you're widening your spread. So on the offer side 2 points higher, and on the bid side 2 points lower, and as a result, what you now have, this is the formula I'm referring to. You now have the bid being 2,310 and the offer at 2,314 point something, and then you just round it up. Okay, now this is how you would trade. And what happens then? What happens then is you wait. Okay, you sit there and you wait until someone sells to you either at this price or buys from you at this price, and then you can turn around and put on an offsetting hedge in the DAX. Okay, now all the discussions that follow, you can see I already have some notes here. Okay, can be traced back to questions 13 and 14, and I think that would be a good continuation of the discussion as to what might happen after you put on such a trade. Okay, ideally what you would like to do is, after someone actually sells to you, so you buy at this price, okay, you are happy to sell at this price, if that really was possible. So after you go long as a price maker on the Euro stocks at 2010, you turn around. So this is, you are a price maker, and here you are a price taker. Okay, you turn around and you hedge right away. If you were so lucky that as a price maker, okay, somebody buys from you at your offer side here, price maker, okay, then these two trades actually are already liquidated. They are finished. So you can actually unwind your hedge by buying in the liquid market as a price taker. So you buy at someone's offer, okay, and that's what this level here is. Okay, so that's roughly the procedure. Okay, so have a look again at questions 13 and 14 as well. Thank you. Okay, let's now take a look at question on the page 20. This is related to lecture number 7 and pages 13 and 16. 13, how to prove the Greeks of early exercise option. Alright, let's have a look at that. So lecture 7 page, so let's take a look at so question 7, I think page 16. Oh, here. On page 13. Okay. Okay, and what we are talking about here is you have a call option, an American call, and the choice is between whether you keep the call, okay, or you exercise the call. And then when you exercise the call, that means you're going to buy the shares, and then you buy the shares, and then you're going to hedge it with a put. Okay, so it's actually just a comparison between these two alternatives, and I think these are the Greeks related to the call option, and these are the Greeks if you were to exercise your call and go long a put instead. What then happens to your package? So either this one, the call, or long stocks plus put. Now if you have a call option, the moment you exercise it, it becomes a long stop position. Long stop position does not have any gamma, does not have any vega, does not have any theta. So your delta this is what's sometimes called delta 1. Okay, you just have you are just taking the risk of the stock. So of course your delta is 100. But here, if instead you are long a put, then your gamma becomes the gamma of the put, and then your vega is the vega of the put, theta is theta of the put, and the delta, of course, is just 100 minus whatever is the delta of the put, the absolute value. In fact, there is another way you can look at this, because the Greeks of an option, which are very, very deep in the money, or very, very deep out of the money, are actually quite similar, except for the delta. Of course, delta goes from 0 to 1. The gamma and the vega and the theta are very similar. So here, if you hold the call to maturity, in fact, these can be the Greeks of that call, which will be approximately the same as the gamma you have for the put and the vega and the theta and so on. So there's a symmetry between the Greeks over here for gamma, vega and theta, and the Greeks over here. Okay, that's the whole point about this slide. The other question is asking how to answer the question, is there any scenario I would like to pay a bit more for this early exercise call? Again, think Greece. Okay, now what does this actually mean? Well, look at it this way. All we are trying to say is, I'll give you an example. Okay, so let's just try and call up our old friend, optionprice.com. EU to retaliate against US bank capital rules. Okay, so optionprice.com. And what I'm going to do is, let's suppose that I have an option. Let's just say it has 60 days to maturity, so a couple of months, and I price it at a strike of 100, and the underlying price is now 120. Now I'm looking at pricing the call. So this one is a deep in the money call. The price should be around $20. Now I know I'm here pricing a European option, but it doesn't matter. Okay, I'm just making a point here. The point is, so there is an option which is deeply in the money, and when you price a call, and if you were able to exercise it today, it has $20 of value right away. Okay, in fact it has some optionality, 75 cents. Now suppose you predict that in the future, in the near future, volatility will actually go up. Let's say you have that view and you are totally convinced you are right. Okay, if you reprice this option with a vol of 35, the theoretical price now jumps to 21.27. Okay, so if you were able to buy such a call in the market being priced at 25 vol, in fact, if this option was immediately exercisable, you wouldn't even have to pay that much. You'll be paying 20. Okay, and yet even a European option, which should always be cheaper than an American one, as you can see, has a price of 21 something. So of course you're going to jump at the opportunity and you don't mind to pay a little bit more. Okay, you can for example, you can buy this option. An American option can do everything a European option can do and more. Okay, so if you were able to buy this, and let's just assume that was trading at $20, that is, okay, so you can buy this American option and you can sell the European one at a price of 21.27. okay, then you have an arbitrage. You can't lose, because an American option where you are long, okay, can more than cover the risk of selling a European option. And yet when you sell, you get paid 21.28, but when you buy, you only buy at 20. So in that kind of scenario is when you expect that volatility will go up, for instance, okay, is one situation where you don't mind to pay a bit more. Okay. Okay, so now I'm going to have a look at the questions on page 21. These are related to lecture number 8, pages 2, 13, 15, 16, 20, 21, and 24. So page 2 of lecture number 8, can't understand the logic behind the conclusion. Adjust model parameters in response to trades. When we continuously sell option, raise the ATM vol, and when we only repurchase, increase the slope, and if we buy deep out of the money puts, lower the put curvature. Well, the thing about trading generally, if you are a market maker, is that, and this applies to anything you trade, anything, okay, when you are a market maker, and this is the page, these are the remarks. When you're a market maker, so you put prices out where you would be happy to buy and sell. Okay, now if you're happy to buy something at $9.90 and you're happy to sell something at $10.10, the more you buy, the more you accumulate a long position, the more conservative you become. So next time round, maybe you only want to buy something at 9.8 or 9.7. This has nothing to do with where the market is going. It's just you want to protect your risk, and the more you buy, the more conservative you become, and then you lower your bid price. Likewise, when you are selling, so when you are selling, the more you sell, and sometimes maybe you become short, the more you sell, you want to raise your price because you already accumulated so many short positions. In order for you to trade even more on the short side, okay, you want to be able to sell higher. Now, this is talking about exactly that. So let's say there's the option market, and the volatility curve looks something like this, and this is at the money. Okay, so these are out of the money call volatility, and these are the out of the money put volatility. Okay, so if you continue to sell at this point, okay, so the more you sell, you basically the next time round, okay, you're saying, okay, I already sold so much, if you want me to sell more, I'm going to raise my price. Okay, or if you want me to buy more, I'm going to lower my bid price. So if you are going to sell, you would want to raise the volatility yourself, okay, regardless of what the market might be doing. And if you're going to purchase, if you're going to buy calls, okay, if you want me to buy, then, well, it depends on what you're buying. So if you are buying a lot of deep out of the money puts and you keep buying and buying, so the more you buy, the more you're gonna drop your price. That's why you lower the volatility. Okay, but if you are repurchasing, okay, if you are repurchasing upside calls, so that means you actually sold some calls, and you are now quite keen to buy them back. Okay, so you don't mind to pay a higher price. That's why you would increase your slope. Now, so I think you don't have to worry too much about the text here, but understand that when you continue to buy something, your price will drop, and when you continue to sell something, your price will rise. Okay, and then page 13, why there is a quicker profit possible if implied vol drops to 24. Now page 13, I think the question here is, if you have an option, so let's take the S&P 500 as an example, and if the volatility is trading around 32, that means the market expects that every day there will be approximately 2% of movement. 32 divided by 16, 2% of movement. And if you think this is too much, so first of all, if the market expects there will be 2% of movement, so if you sell the option, that means the time decay, the theta, first of all, you are receiving theta, and the theta will compensate you to the degree of a half gamma sigma s all square. Okay, and if S&P 500 was let's say 2000, then if there is any movement in the S&P 500 which is 2% or less, okay, then you get to make some money, because the theta that you will be paid every day is driven by a movement of at least 40 points. So anything, if it moves less than 40 points, okay, then the theta you receive will more than cover the gamma revenue, or the negative gamma revenue, because now you are short the option and you are hedging it. Okay, now let's say you have a view like that. So the point is, there are two ways you can look at how this money is made. So first of all, every single day, okay, the theta would cover, or I could draw it over here. So the theta would cover this amount of gamma revenue loss that you are going to experience. But let's say the market doesn't move by that much, and the market only goes up to here, okay, then the difference between this one and this one, which is this little bit here, okay, becomes your profit. So every single day you get to actually pocket that, because the lack of volatility, or the smaller than expected market movements up or down, means that after hedging for the gamma revenue, or I should call it gamma expense, because it's not a revenue for you, it's a negative revenue. The gamma expense is less than what you get compensated for via the time decay. Okay, now so day after day after day you make money. However, when you look at option pricing, so let's say something was let's just price something at the money, okay, and let's say I price this option starting at a vol of 32. Is this the right price? I don't think so. Okay, so now the call price is $5.48. Okay, now if the volatility doesn't happen, then there are one of two scenarios. First scenario is this option in the market is still being priced by other market makers at 32. Okay, in that case, you every single day you will just be able to keep that little bit of gamma revenue or gamma expense. Okay. Alternatively, the market may actually start pricing the option with a much lower vol. So let's say 24. Now, the price now is 5.48. The moment the market starts pricing at a vol of 24, your option price will drop from 5.48 to $4.20. Okay, so there's actually a $1.20 profit. Now this can be an instantaneous profit. You don't have to wait. As soon as the market starts repricing, you can just buy this option back at a lower price, and then you get to keep that $1.20 P&L. Okay, so this is kind of like crystallizing or realizing the gain without needing to wait, because the entire market now realized that that option shouldn't be priced at a vol of 32. That's why there'll be a quick possible profit if the implied vol drops and the whole market now is pricing that option at the vol of 24. Okay. Page 15 to 16. Why the Nikkei example is risk-free arbitrage. Okay, let's look at page 15 and 16. All right, now here we have two options where there's one from now to April, and that option is trading at 280. There is another option from now to July trading at 265. Now I don't actually believe that's possible, but if it were, now the July option, since it has a longer tenor than the April one, it can do everything the April one can do plus more, because I have some additional optionality from April to July. Okay, so if this was the case, I would simply sell that, and I would so I will short this one, I will buy this one, and I don't have any risks, because you know, if I sell the April and someone makes a claim, I have the July one to hedge that, and in any case I get an extra 15 points because I sell at 280, I buy at 265. What's more, after this April option expired, if nobody claims on me, I now have a free option between April to July. Okay, so like I said earlier on, when somebody was asking me about arbitrage, the test to do is always, you know, if I have a strategy, whatever it might be, okay, you don't have to think about, oh, do I always buy call, sell put, long stock, and so on. You just think two things. Okay, one, does this strategy always either make some money, or at least you don't have a loss? Okay, so your P&L is non-negative. Non-negative means zero or positive. Okay, and the second thing is, can it actually finance itself? So you don't need any money in your pocket, and of course this one can finance itself. If you're going to buy this 265 at 265, you just have to sell another one at 280. So you get the money to pay for July put with the money you get from the April put. Okay. What else? Page 20 to 21. What is the logic behind these graphs? Why some are linear, some are curves? Okay, page 20 to 21. These are just graphs telling you what is your profit and loss according to whatever is changing. So market direction means if you are long a stock, then as the stock goes up 10%, of course you have a profit. But if the stock goes, if you are short, if the stock goes up 10%, then you have a loss. Okay. Now the diagram on the next page. If you are long or short volatility, okay, that means if you are long, this actually is it's assuming that you are long. Okay, what does long volatility mean? It means you are long options. Doesn't matter put or call, just long options. Let's say you're long put, okay, and you have a delta hedge. Okay, so you are just trading gamma, and you are trading volatility. Okay, then what happens when volatility goes up or down? Okay, so first of all, when volatility goes up, you will make money, and volatility goes down, you will lose money. I actually I don't know that this is perfectly linear. When an option is at the money, it is true that when the volatility increases, let's say 1%, 2%, 3%, the increase in the option price is fairly uniform, for the simple reason that your vega does not change all that much, and we discussed this on numerous occasions. Okay, so it's all connected. But the vega does change a little bit, but actually very little. I have to say, for at the money options. Okay. Now, what about the graphs of the top ones? So this is saying that you start off with a negative. Okay, of course you do, because you bought options. So this negative amount here represents the premium you paid, and if you are delta hedged, then when there's a lot of movement in the market, either up or down, okay, that's when you start to make money. So it can go either way, and it's not linear. Okay, and then if you are short, of course the exact opposite is happening to you. Okay, so you don't want to have a lot of movements. You want the market just to say exactly where it is, and then you get to make this money due to the lack of action. And then when the market starts to move, there comes a point when the theta that you are receiving will just cover the gamma expense, if you like, although no one calls it that. The gamma revenue that the other party gains, which is your loss, and then beyond that, you start to run losses. Okay. All right. What's the next one? Page 24. I cannot understand the example. Now, what's page 24? So 21, 22, 23, 24. Okay, this is again another fine example of trading markets that are normally fairly well correlated, but occasionally one of the markets actually just goes off completely on its own, and if you think that market will actually come back, and then some kind of convergence will take place, then you have an opportunity. For example, let's say the Korean market is quite correlated with the Hong Kong market and the Japanese market and the Australian market, or maybe even the China market. Okay, so normally they would sort of trade like this. So this is the Korean market, and this might be the Japanese market. And then one day, suddenly the Japanese market is dropping quite fast, but the Korean market dropped even more. Okay, now I'll tell you how that can happen. For example, there is some economic news affecting the Asia Pacific region, which is not very good news. So all the markets start to fall. In addition, that guy in North Korea suddenly fired a missile into the South China Sea, for example. Okay, so Korea, aside from the overall, common macroeconomic factors, now has an additional complication. Now, it is possible that the Japanese market will also fall, but maybe not by as much. So maybe in an extreme case, okay, in Japan it falls by 5%, which is already quite a lot, okay, and then in Korea it falls by, let's say, 12% or something like that, okay, and then the volatility of options, of course, will shoot up, and now, of course, you are trading option volatility, okay. So maybe volatility of the Nikkei 225, okay, it goes from 18% to 25%, okay. So the Japanese market is nervous, but the Kospi, the volatility of Kospi was at 18, and it now goes to, let's say, 35, okay. Now that can happen because the different markets, the way they assess geopolitical risks they are correlated, but they don't have to point for point move in the same way. And now you say to yourself, well, this guy in North Korea, he's done this before, and if history is any guide, okay, then the Japanese market will calm down later on, and maybe will resettle back at 20, okay, or whatever, okay, and the Kospi market will also resettle somewhere, let's say at 22, okay. Let's just say that is your theme, okay. Now you can see that they have diverged, and there is a gap. There's a 10% gap right now when the markets are so nervous, and you think that in the future that 10% gap is going to shrink and become a 2% gap, okay. Now I ask you, if you really have a view like that, and if you are 125% rock solid confident that this will happen, how are you going to trade this, okay? So of course you are going to short. You want to short the Korean volatility, and you want to go long the Japanese volatility. And when you do that simultaneously, it doesn't matter which direction they go. What matters is that if you are going to long this one and you're going to short this one, what matters is that the gap has to close in, okay, from 10 to 8. And it doesn't matter whether it's the Japanese vol going up or the Korean vol coming down. Quite likely it's going to be a bit of both, okay, and that's how you would make money. Okay. I'd like to now have a go at question on page 22, which is related to lecture number 6, pages 4 to 10. Could you please explain more about the volatility curve? I don't understand the lecture notes about this part. Okay, so lecture 6, page 4 is this one here. So page 4, this is really just what practitioners do in a multi-step process when they look at the option market that is really trading out there, and typically you see people are buying and selling options that are either out of the money call vol and put vol for out of the money puts. And quite often what happens is that when people are buying or selling out of the money puts, the volatility is quoted at a much higher level, and there's a kind of curve that dips and then it rises again. Now this is the market pricing in, I guess, a greater chance of a market crash or a greater chance of an extreme down move or up move than what your normal distribution may actually suggest as these tail events. Okay, so in other words, it's trying to price in the skews. And the way to do that first is at the point where it's exactly at the money, you first determine what the slope is, and then it's really just trying to retrofit using very simple parameters. And of course you can see the volatility is not a straight line, it's some kind of curve, so you got to apply some curvature to it here and here. Okay, but when you do that, if you don't make any adjustments, it would go off to infinity, both on the upside and also on the downside. So round about here you have to make some adjustments so that it actually goes smoothly like that. So it's a process of one, and then the curve, and then adjusting it down. Likewise on the other side. Okay, that's what these slides are talking about. It's just how practitioners try to use simple parameters to fit their quoting methodology, which is consistent with where the market is trading. Okay. The next one I want to tackle actually is question 23, related to lecture 4, page 38. Can you explain the mechanism of the right hand side graph for Vega? Why is there a fat tail of Vega with a higher volatility? So lecture 4, page 38 is, I think, this one here. This is lecture 4, page 38. So the student is asking, why does the graph look like this? Now, so first of all, this is a study of how Vega changes as the spot price is changing. So it's called D Vega, D spot, sometimes known as Vana. And then it's different. So Vana, so first of all, Vega is highest when the option is at the money, and then it Vega drops. So, or the option is not so sensitive to volatility change when you start moving deeply in or deeply out of the money. For low volatility stocks, that Vana parameter seems to be a lot higher, so it changes very fast, whereas for high volatility stocks that's not the case. To really answer that, you have to look at what's actually going on with the definition of Vana, which is this formula here. For options, let's say for stocks where there is no dividend, you can actually define it by this formula here, which is Tn-D1 1 minus D1. Now, first of all, you have to get an appreciation of what D1 is, which is this term here. So there's a sigma here, and there's a sigma here, and then N-D1 is just e to the minus D1 square times 1 over 2 pi. The reason there is an asymmetry is when sigma is very, very low, I guess the dynamics is different because sigma appears here as well as at the bottom, and it's approximately symmetric when sigma is very small, and then when sigma is actually quite high, then what you do is as you get more increasingly in the money, when you are in the money, then this you can tell. Let's say an option has a strike of 100, and let's just say that if the spot price was, let's say, 125, so it's already fairly deep in the money, in which case, this parameter it wouldn't change all that much from 120 to 125. Then how Varna changes depends on what is happening at the back here, and it just so happens that when sigma is very small, the Varna value actually is greater. Okay, that is why when sigma is small, you have a more rapid change in Vega than when sigma is large. As to why there is a tail here, isn't that fascinating? Okay, if you really want to know, you can trace that by simply studying this ND1 parameter and how you probably need a three-dimensional analysis where you are changing S at the same time as when you are changing volatility, and you want to study what happens to Vega. Okay, you'd find that, yes, Vega. Okay, you'd find that this term it tends to come down, okay, as volatility goes up, because the sigma is hiding here and also here. Okay. Okay, now I look at question 24. So this will be, I think for now, for the last question that I have picked up in the Google document. So it's regarding lecture 5, pages 54 and 55. So let's have a look at that. So lecture 5, pages 54 and 55. Greed and fear. Okay, the question is as follows. So professor says when share price increase, volatility would decrease, and my out of the money call Vega, so called delta, should go down. But when earlier it says when share price increase, delta of a long position should increase. So these two, they seem to contradict each other. I think the problem here is that you really want to, you would like to, or you are trying to memorize some kind of hard and fast black and white rule of what really should happen to a call delta when the market is rising. Now, and the problem is, I think we are mixing two things. So first of all, there is the so when you have an option, a call option, and before, let's say the price was here, and let's say the strike was 100, and the spot price currently is 90. And if it goes to, if the spot price goes from 90 to 95, now as I have said many times before, of course your delta will increase. So mathematically, when you have let's say an out of the money call option and the market is rising, the delta of the call also will rise. Now this is a simple, clear-cut mathematical outcome, so no one can argue with that. Just like when I price an option, so let's say I price a call with a strike of 100, and the spot price is now 90, then you can see that the just hold on a second. So let's say I price a call option where the so sorry about that, the exercise price is 100, so strike 100, underlying 90, and the call option price is around 74 cents, and the delta is 0.167. Now if the spot price goes to 95, of course the option price will rise, and the delta also will change. And when you do that, the delta has increased. Now that, as I said, is a simple mathematical reality or theoretical outcome, so you can't argue with that. When we say that when the spot price increases, volatility tends to go down, okay, now this is not a mathematical outcome. This is more sort of an empirical observation. Okay, this is what practitioners actually observe in the market. Nobody says it has to be this way, okay, but you know what, in reality it does happen. Okay, so what happens then is that as the vol goes down, then so basically this is like a two-stage approach. Okay, so first let's say you were here, okay, and then this is your delta, and then the price rise, so this is your delta now, so your delta has gone up, okay, but simultaneously now, because of a drop in vol, and your option payoff curve might look like this instead, okay, your delta has gone from 1 to 2 to 3. Now these both things are happening at the same time, so it's kind of from here, and it steepens and then it flattens again, and like I said, one of them is a mathematical outcome, and the other one is an empirical observation. And if you are a trader, then, or if you are a student, okay, you learn this from books, or at least now you learn that from us. But this is something that you observe from experience, and you have two effects basically offsetting each other. So there's no real way to say that which way the delta would go as the market is rising. The books will tell you that, oh, delta would go up definitely. Okay, now the books don't tell you that when the market is rising, volatility has a tendency to go the other direction, because everyone is kind of quite comfortable with the market condition, and the sigma parameter is the market's way of expressing how volatile they think the future market okay, not the past, the future market will be. So when markets are rising, people tend to be more comfortable, and as a result, sigma will fall. So when you combine these two, no wonder there seems to be a contradiction. There isn't. Okay, so the first one is a simple, textbook rule, and the second one is what really happens in practice, and these will drive the delta in different directions. So if you were to do that here, then I guess after the market has gone from 90 to 95, and you look at your delta and you say, oh look, my delta has now gone up to 0.31. Well, if the market then trades at a vol of, let's say, 20, then instantaneously, okay, then your delta will actually go the other way, okay, and it will drop from 0.31 to whatever value, 0.27. Okay, so that's the reason for that. Thank you very much.